what the hell's the number? 22.5? Yeah.
Mm-hmm.
So, for exercise 22.5, starting with complement, what were you saying?
Yeah, if one machine accepts, the complement machine needs to reject, and vice versa.
And vice versa.
Yeah.
Yep. How can we define that in terms of the rules of the machine? If we have the formal description of the machine, what do we have to change to make this the case? Let's say we have M and M prime. M is the starting machine, and M prime is your new machine. And we're going to define M prime based on M mostly, but we're going to make some adjustments.
Well, it can't be in sigma, right? Like, the X can't be in sigma.
Let's go. It's not sigma that you need to adjust.
Oh, it's not sigma. Okay, got that.
What did you say the difference was for complementation? Anyone can.
You just have to swap the
answer
accepting
the
and
question
rejecting
I'm asking.
states.
Yeah.
You have to swap. That's the only thing you need to do. Okay.
I mean, think about it. If all you do is swap the accepting and rejecting states, which is, so this is an 8 tuple?
Yeah.
It's an 8 tuple. And so we're talking about swapping the 7 and 8 of the 8 tuple, right?
Okay.
And then, I mean, it's just by definition of the first machine. The second machine is going to, well, if the second machine rejects, it did exactly the same transitions as the first machine would have done, and it ended up in the reject state. But in our original machine, the reject state is the accept state, and so it does the opposite. And then the same thing for the other state, right?
Mm-hmm.
It's, if you accepted whether you accepted or rejected with one of these machines, you ended up in that state by the transition rules, and reading a particular input, and now you're saying, well, this other machine reads that same input, follows the same transition rules, so it'll end up in the same state. It's just that state is now the reject state. Or the
Wow,
accept
that's
state.
really simple.
Yeah, it's simple. Just don't lose points on it, right?
Just
because it's
literally
simple. I
write
want people
out
to
the-
like make sure that.
So here's my question.
you
On,
know everything.
on Piazza, they said we need to give a formal Retro said we need to give a formal definition and
Sure. So what's the
kind of-
formal definition of, let's say this is the formal definition of the first machine. What is the formal definition of the second
You
machine?
just
It's
write down
exactly
all the things.
that, but
Q sigma, the tape.
it's
blank.
exactly that, but you flip the A and R. Okay.
But just be very clear that you're talking about the same states as the first machine, all elements of the 8 tuple that describe the machine are exactly the same as the first machine, except, the 7 and 8, which are swapped. You're not going to be able to find a particular machine, right? You're not going to be able to say this, these states.
Yeah, okay.
Everything is defined relative to the first machine. You can think of this kind of like a function, right? You're almost defining a function that takes a machine in and outputs a machine that's out that can decide the complement. And because it works for any machine, you've shown that they're closed under complementation. That because there exists a machine for a language, there exists a machine to solve its complement, to decide its complement. Hey, so we're just going through 22.5.
That makes perfect sense. That's
Yeah,
what
sorry
I'm
about all the wires.
That is my fault.
It's good enough. I'm not even writing anything on the board yet. Some things that are this simple, I don't even like to write on the board, because then otherwise, people can just skip to the end and see the answer on the board. But it's cool. I got it. I mean, it's super tilted. I'll fix it. It's annoying to fix. Let's see.
Oh, the intersection one's going to be a little bit more interesting.
What?
The intersection one's going to be a little bit more interesting.
Intersection is going to be more involved. The complement's a nice warm up and lets you know that you at least understand the basic from what happened here. All right. Offset. That's pretty good, right? Now it's very tilted still. That's not just me, right? That's super tilted.
Mm-hmm.
What are you going to Michigan for?
Tennis.
Cool.
Yeah.
Varsity tennis?
Yeah.
Okay. I think we got an email about that recently.
Oh, what?
Well, somebody sent in homework for varsity tennis because they had varsity
That
tennis.
was probably me.
It's fine. Understandable. Good luck.
Thank you. Jesse.
No problem. So, right. What were we talking about? Do you have a
About the
particular question?
complementation. Or no.
About the intersection, I was getting stuck.
Okay.
And I can
Yeah.
remember what I had, but
Intersection is definitely going to be trickier.
Yeah.
So, we have two machines each decide language. So I see the easiest way to do it. You could probably be doing some kind of way of simultaneously solving both, deciding if it's in both languages. That sounds kind of hard.
yeah,
I wouldn't do that. So sometimes, full disclosure, sometimes I give how I would solve it, and I talked to Richard and Jafar later, and they have definitely a slightly better way to solve it, or more efficient. Still, my way works. It's just the first one I think of. So just because I think of a way doesn't mean it is the easiest way, but I definitely wouldn't want to dive into trying to decide both at once. So let's say we have a machine M1 and M2 deciding some language, and we're deciding two different languages, well, possibly two different languages. They could be the same. And we want to build a machine M prime that accepts their intersection, right? Well, how did we do this type of thing with... So with DFAs, you actually kind of combine the two things. But can we do anything more like concatenation of DFAs that would be effective here?
so I was thinking, one idea I had was that if you have two machines, intuitively what you should be able to do is you run it on the first one, see if that accepts. If that accepts, then you move on to simulate it on the second one, and if that accepts too, then you go to your proper accept state for this guy, the intersection you're constructing.
Sorry, say it one more time.
So you run it, so intuitively you simulate on the first Turing machine. If that gets to its own A, so A1, then you start simulating from there, pretending it's the Q naught of the second guy. If that also gets to an acceptance, then you accept. But the problem I was running into was that when one Turing machine processes it, it could do anything it wants with the tape, so the entire string that you start with could get removed.
Yes.
And you want to be in a state where it's Q naught of the second Turing machine B, and then the
Yes.
entire string again. So I was thinking of ways to duplicate the string, but I have no idea what the first machine could do with the tape.
Yes.
So
So duplicating the input is a good idea. And it's probably what I would do. So it's going to have its own complication. So I suspect there's some way to do it by merging them. I don't know. I can't think off the top of my head. I feel like once you think of one solution, I sometimes get stuck in that solution. But it's hard to think of another totally different one sometimes. But anyway, so there's probably a way to do it by combining, and I'm sure that has its own complications. The complication with this approach is that the most obvious way to do it involves copying the input. But, so we're assuming that Turing machines are infinite in both directions right now? It's unfortunate. If it was, so,
yeah.
because if you had, if you work with these things for any amount of time, you realize that and I think he actually even says it in lectures, so maybe we're allowed to leverage this. So he says, does he specifically say it's equivalent to have a machine, define Turing machines as only being infinite to the right?
He says that vaguely. He says, I usually go with doubly infinite as it is technically a bit more convenient. First paragraph.
Okay.
Turns out not
Do we
to
consider
matter.
this saying, so let's assume for now that we can say that a Turing machine that is only infinite in
Okay.
right of the input is equivalent in power, computational power to certainly at least in computability to one that's infinite in both directions. Then can we figure out a way to do this effectively?
Yeah.
So what would be your method?
You shift the string right. So if you have
Grab the black marker off there. Because I think this is the easiest way to think about it. We can later adapt this if we want to an infinite in both direction of
So
the method.
what happens is at the beginning, before you start running any machine,
Yes.
what you could do is you do this, and you basically in your like initial step you duplicate it over here, and and you start off your first machine over here.
Yes.
And so by definition, if it's only using things to the right, it'll only use this, which means this will never be affected. And then when you're done, you clear these into blanks
Yes.
and run the second machine here.
Yes.
And if both get to accept, you accept.
Yep, that is exactly what I was thinking of doing.
Okay.
So
Do you need to put a blank in the middle because it says it starts?
it doesn't. It's easiest if you put a blank in the middle, because then what you can do is, there's like you never allow other blank spots. Well, the computation itself, it's probably easiest to do a blank in the middle. Yeah, just because during the copying step, then it's obvious when you've left the first string.
blank
Like if I'm copying that to the right, then I hit a blank. I go one more to the right without writing anything, and then I go to the right until I see another blank, and place the symbol there. What I mean is this. I'm gonna give a specific example of how you do something on a really low level. So if you had like, is this still on the thing? God damn it. So, yes, it was good. You have B here and X here. These aren't single cells. They're that. Then what I do is I read the first symbol of B. So one thing you can always do is expand your alphabet. This is like a really simple way to deal with obnoxious cases. And so like let's say I read 0, then I replace it with 0 prime. Move all the way here, I see a blank. And so, honestly, priming the symbols in here is probably like the easiest thing. So expand my alphabet so it contains 1 prime and 0 prime. Read the first bit of this. Go right until I see a blank. Then put the if I saw a 0 prime here, then I'll be in a state that places 0 here. If I read 1 prime, I instead place a 1. I do like the blank actually. So we'll do a blank. So, starting that over. If you see 0 prime here, so if you see 0 here, you replace it with 0 prime. You move all the way over here, and then you see the blank. You skip that spot, and now you want to read until you see another blank. So let's say you haven't written anything yet, then the next one will be blank, and you replace that with 0. Next, you go back here until you see a prime symbol, and then you move 1 to the right to get to a not prime symbol. You turn that into a prime symbol. Let's say it was 1. You write 1 prime. You trace all the way back over here. You see a blank, and you know to switch to states that they'll trace all the way over this until they see the next blank, which is here. And it writes 1, because it saw 1 prime over here. Because it saw 1 over here and replaced it with 1 prime. Then, the reason to prime them is just to know what you've worked on. That's the only reason to be doing this prime thing. Expanding the alphabet is one of the easiest ways to get around obnoxious things about Turing machines, I would say. I wrote a 500 Turing tuple line code once. So that was so expanding the alphabet was one of the easiest ways to reduce it from thousands of lines to hundreds of lines. But yeah, does that make sense? Do you see what I'm doing? So
Really?
Okay, so the whole point here, we have a machine. Let's say we're just trying to decide M1 without disrupting the input. Okay, because M1 can just tear the input to shreds and then just output whether it's in the language M1 recognizes or not, right? But we want to be able to check for containment in 2 languages, right? So we want to preserve the input after the computation of M1, okay? So we're assuming for now that M1 is a Turing machine that computes on a write-only, infinite to the write-only Turing tape. There's a bunch of issues we're going to have to deal with. The first thing is we're going to have to do this copy step, which is what I'm describing here. But let's presume we've already copied, a little blank, that we've already copied our input. What is X? B is the input? X.
B is the blank, X is the input.
Oh, you want a blank at the start too.
That's
to
how
keep
he
it from
defines
multi-
it. He defines it as in like you start off and the first.
You're
thing
right,
you
I
read is a
did see
blank.
that. Yeah. Everyone defines it differently. Anyways, okay, so this is the blank at the start, and I guess this is the blank, right?
Yeah.
And now I'm building X over here. So good that I can erase this. Sorry. So we see the blank, we see our input X, and then let's say magically we copy X over to here. Okay? The reason we're doing that is because then we're going to simulate M1 on this part of the tape. Because it's write only, it won't go over here. One thing we have to be a little careful of is M1 can, in a write only model, we're not going to have to be careful of this because we aren't using write only machines. He only defined the infinite in both directions. This example is still helpful. In the write only model though, technically it could try and, usually it's allowed to try and leave the tape, and if it does, it like halts and rejects. Like there's often some convention for what happens there. We would have to replace that convention with something to make sure it doesn't drift off, because now there is something to the left of it, right? But ignoring that corner case, let's just say it only stays on this part of the tape. It does its computation. We have no idea what happens to all this stuff. After we find, if it's not in M1, we just reject, because we're looking at intersection. We want to know if something's in the language of M1 and M2. If it is in the language, we erase all this work, and then we move over to here. We do have to be a little careful though. I think to erase all of this work, we need to actually be maintaining some weird end symbol, right? Because otherwise we don't know where M1 stopped writing new symbols. So one thing we would have to inject into M1 is we would have to somehow modify the states, right, to maintain some special end of tape symbol, or we wouldn't know when to stop erasing. And we'll probably still have to do that in the one, I think, in the other solution. Does that make sense? It's ugly, but
In the other solution, you mean the complement?
No, in like the solution where we're not talking about a write-only model.
Okay.
We should, if we're gonna run, like let's say the input is still there after M1 runs, okay, on some infinite in both direction tape. Magically the input's not affected, so X is gonna be there, but we have no idea what's happened on the rest of the tape while M1 was running. This could affect the computation of M2 though, right? There's just random symbols floating around where M2 usually would only have blanks. M2 might make a mistake.
You're basically isolating M1 and M2 by
Yes.
putting the blank and the star from
Yeah.
the rest of the tape.
Basically the star symbols at like either end would be there to make sure you knew where the computation of M1 was contained within. Like what it affected. Does that make sense? Because otherwise we would have to keep going, like, yeah?
No, finish what you're saying.
So, here, it's getting a little complicated, so I think I'm going to erase this for now. And just make it look a little less complicated. Yeah, actually I like that one. So we'll have X, and then stuff, and then a star somewhere. So basically, M1 is going to work on this. It's going to start here, right? So M1's going to start looking. It's going to do some computation. Let's assume that this part doesn't change, which is a big assumption, but it's fine for now. Then M1 could have like a ton of blanks here, and then some symbols here. So now let's say I want to run M2 on the same input. I've assumed for now that this input's still here and that I didn't ruin everything. Then I start here, I start running, I start doing things, but let's say that M2 uses more space. Let's say it writes more things, so far past where M1 was working. Well then at some point it's going to get here and be doing some work on this cell. But this cell should be blank, right? By M2 is built to run on a blank, the input, and then just blanks in either direction infinitely. M2 is only built to handle that case. So if we have some symbols lingering here from M1's computation, it's gonna screw up. It could potentially screw up M2. So the thing that you would have to modify M1 to do if you're gonna do it this way is you'd have to modify it to maintain some. This is the last cell I've worked on symbol, and then after M1 runs, it's going to erase this symbol and everything before it up to this symbol, and excluding the input. Does that make sense?
Why up to that symbol?
Why up to the symbol?
Like the other side.
If it's infinite in both directions.
Oh.
Yeah. I'm
Can't
going
it
back
just
to the
erase
infinite in
till
both
the
directions
blank
model.
or the start?
Okay.
Right, because the M1 could work. We don't know how far M1 has written things in either direction.
Oh.
But like so one thing I don't understand how we can then maintain the assumption that BX doesn't get modified.
You can't.
That-
We're gonna.
Yeah.
I'm doing a hypothetical model of just explaining why we need some kind of way of telling what the bounds of M1's workspace
Okay.
was. Does that make sense?
Yeah. If we allow the assumption that the single direction infinite is allowed,
Mm-hmm.
then I think we don't need the star if we slightly modify what we're doing. Like basically what you could do is like you duplicate instead of again to the right, you duplicate in the reverse order going left in the doubly infinite case, assuming both of your starting machines are singly infinite. And then what you can do is you run the first one right in the normal way, and then you run the second one left with the L and R flipped. And that way they never touch each other.
Yes,
And you never
that
have-
is a very good idea.
You never have to keep track of count, because you never have
Yes,
to clear.
you still have to be careful about the corner case of when they go off the edges.
Yeah.
And the problem is, I'm not 100% sure we can really use this assumption of like, so the easiest way to do it, in my mind, is exactly what you're saying, which is you say, okay, well because their M1 is computable, we know that there exists a Turing machine that computes the language that like we know there exists M1 that decides the language and like in particular decides it on a write-only Turing machine model, right? And similarly for M2, but for a left-only Turing machine model, which we can get from the existence of a write-only Turing machine model. Then we make our intersection machine on the infinite in both direction model. Does that make sense? I think that's the most elegant way to do it. Problem. We are going to need to modify the machine's behavior on how it deals with possibly moving off of the end of the tape. Right? Because we don't want it to actually ever do that. In the write-only model, it could like try and move off the left end of the tape, and then it would automatically halt type thing. Like there's often some convention.
Okay, so
And the problem is what is the convention by his definitions? We don't have one, right? Because he doesn't even define the model.
Yeah.
So I'm not sure how we augment a model that we don't have a definition for. Does that make sense? It makes it hard to use this notion that there is a write-only model that works.
okay, but I think so if we had a definition for that,
Yes.
I think you can augment it pretty simply. You put a star in the middle. If you ever get a star, you're done.
Yes.
But like, are we allowed to use it?
I want to say yes. Give me a minute just to see if Stuart's on it. We're definitely particular about notation, and so I want to make sure that this is something that's kosher. And I'll just check these down off. So I'll be back in a sec.
Rainbow keeps updating the Piazza post answer like every 5 minutes.
Does anyone know if the final is cumulative?
No idea.
Okay.
You can do it that way. If you offer a reasonable definition of it, like the right-only model, then it's fine. So you could just like come up with a reasonable definition of, okay, like this is the right-only Turing machine model. There's an easier way to do it though that harkens back to my earlier advice. So all of this is cool, and your construction will definitely work. It'll also definitely take more time.
Okay, I don't
Then
want more time.
the so okay. So I see something better now than what I was doing before where I modify the alphabet, but once again modifying the alphabet is going to come to the rescue. And so what could I have done instead of replacing what is another modified Turing machine model that would be really convenient right now?
You have 2 tapes.
That is, so I don't know if you talked about it in class at all, but you could have, potentially, theoretically, you could have 2 separate tapes with 2 separate heads doing various computations that don't affect one another. So we can see immediately probably how that would be very useful for this problem. There's a reason you don't need a 2-tape Turing, like, there's a reason these models are equivalent, right? So can we come up with a way to kind of trivially simulate 2 tapes? The only thing we have problems with is that we can't have our read-write heads in 2 different positions. But I'm not even sure this answer is easier. I think it will be. But we'll have to discuss it for a little bit for me to see. But yeah, so what is a way that we could maybe like, both tapes are going to have a first cell, right? And they're going to have like a 1 to the right cell and a 1 to the left cell or a 5th cell to the right of where you start, right? Is there a way we can contain the information of multiple tapes in a single tape in a way that seems like pretty simplistic?
You could change the tape alphabet to have Cartesian products of the 2 alphabets,
Yes.
but I don't know how to actually.
Hmm?
I don't know how to actually move after that, like left and right.
Okay. Let's try this idea. Where'd my marker go? Over there. The black one's the best one. Thank you. So, let's say, I actually love Turing machines. I guess I'd better as a theoretician, but I didn't like Turing machines, I'd probably be in trouble. Let's say the first bit of this is the rest of x. And let's say the first bit of this is 1. Okay? And let's say I was trying to think of like a 2-tape problem, and I wanted this tape to be 0 here, and then like some different x prime. So I could store the information of, let's say, so this is tape 1, tape 2. I could store this information, I'm back to the right-only model just to simplify my life, but you can think of it as infinite over here if you really want. I'm just not going to write over there. Well, we can think of a, I don't know what to call it, like 2-tape, I don't know. We can think of it as having a blank here. There's an ugly tape. Blank here. 1, 0 here, an ordered pair. pair of elements from like x and x prime, right? Something like that. Let's say I wanted to simulate what was going on tape 1. Let's say I have a machine that decides some language in tape 1, and instead I wanted to solve it on 2 tape. How would I define a transition function how would I redefine a transition function from the machine working on this tape to one in this new language, right? Because the transition functions here are all defined with respects to 1 and 0, let's say. So how do I redefine them to take in this input and do the appropriate computation?
I don't know if I'm understanding, but maybe do you define like the first machine to take the first element in the tuple? And
Yeah,
the
you're
second-
understanding perfectly.
The second machine to take the second element?
Yes.
Okay.
So let's say that it goes from state Q1 to, okay, well, first of all, I should probably stay in the camera because I'm pretty sure I'm well off it now. Someone define, what's the transition function tuple? Can someone give me all the elements of a transition function? All the pieces, I should say.
Yeah, one sec.
So we've got some particular transition.
Goes from Q set minus A and R across the tape alphabet to Q cross tape alphabet cross whatever the third thing was.
Tape alphabet is not this, right?
LNR.
It's the
Gamma.
yeah that
To Q cross gamma cross LR.
2 cross
Q
cross.
Q, right? What was I saying? Q.
Q cross
Gamma.
gamma cross LR.
Am I gonna fit?
Come on.
Yeah, you'll be fine.
Oop.
LR.
Cool.
LNR are set.
Good point. You can do it either way,
Yeah.
I guess. Can you? No,
Well,
no, you
it's
can't.
as
Don't
a
do it.
tuple,
Don't do
it's
it as
kinda
an
confusing.
tuple. Don't listen to me. Okay, so it's gonna go from some state, let's say Q1 to Q2. We still want our machine M1 to do that. It doesn't take something from the tape alphabet. Now what does it take in?
O1 cross tab 2.
Some element of,
You should say tau 1 cross tau 2.
wait, isn't it gamma cross gamma?
No, it's not tau. It's
It's
Yeah, that's
what you were saying. Sorry, I always get confused.
PL?
I don't.
It's like some,
I got a grade maybe for.
it's some, like, alphabet character A, where A is an element of gamma cross gamma, right? Is that right?
Yeah.
And now what we want it to output is, well, let's say no, we define it on, let's say we had an element A here in gamma, and we write an element A prime here, that looks like a Q, A prime here, also in gamma. Then what we take in is a tuple, A and B, where A is going to be the same, right?
Wait, how are A and A prime both in gamma?
I mean, I don't know what they are. They're 0 and 1 maybe? Or 0 and 0? They could be the same element. They're just elements of gamma. Like this is, I'm defining a
But
particular...
A is gamma cross gamma, right?
Hmm?
But A is gamma cross gamma, right? Or is this A
This, so
different?
this is the original transition function, and we want a new transition function. on
Oh,
our
I see, I see, I see,
Yeah, sorry.
I see.
Let's
Okay,
call this primed or something, I don't know.
I get that.
And I should replace this with a particular element too, I guess. This should be Q1, right? So let's say we have Q1 and what's X, right? It's just A.
Yeah.
Okay? So we have a transition function that says Q1A to Q2, which could be the same because I don't know anything about my transition function. It does something like this, right? Our original transition function. So our new transition function is going to take Q1. I want to separate these from commas somehow, because there's a lot of commas floating around. Q1 still goes to Q2, and it maps to what? What's our new character in the same cell? So we're trying to run the machine that runs on the tape 1, but on the 2 tape now, without affecting the second tape.
So for tape 1, it would be A prime B, right?
Exactly. Cross
Why B?
L or R, whichever element. It's going to be E plus, and then L or R.
Should these be cross or cross?
No, they should be cross. That's why I was erasing them.
Wait, I'm confused. What?
Let's say L.
So, why B?
B is just some symbol from the second tape.
So we're not transitioning on both?
No, because the whole point is we don't want to affect the second tape,
Oh,
right?
okay.
We don't have to copy the input if we, I mean,
I see, you're not doing the simultaneous one. You're doing
I'm
the
still doing it sequentially,
yes, okay, cool.
but my method of maintaining the input is different. Both will work. The way of copying the input to the left and making this argument about leftmost only or right, left infinite right only and infinite left only Turing machines, their existence, and then writing a simple definition for what they do at the if they try and run off the edge, and dealing with that. It just sounds like a lot of corner cases, right? Like in that sense, in some sense, neither one is gonna get away from the fact that you have to dig into the transition functions and define new transition functions based on the old ones, right? Because for this one, you have to modify like all the transition functions. For the way you're talking about, you actually barely have to modify them, right? Because you're arguing about the existence of one that works only to the right, M1, and you're arguing about the existence of one that works only to the left, M2. And so then you just need to define new transition functions kind of between the two, right? So like I would say your method requires more general definitions, more complicated like general definitions, because you have to be careful about defining the infinite to the right and infinite to the left only machines. That's like the tricky part there. The tricky part in this one is just making sure that you redefine the transition functions appropriately. And of course you'll want to reset to the beginning of it after solving the first one, right? So pick your poison, I guess. But I do think this one's probably a little easier. I don't know what your thoughts are.
So I'm gonna watch the rest of the video because I have to run.
That's fine.
But
Go for
yeah, can I talk to you about that question on Tuesday?
it. Yeah, definitely.
Perfect.
But yeah, does this make sense to people? I mean, yeah, you're right. You're like, I don't know if I'm understanding this, but yeah, that's really all there is to it. Is you.
I understand this because I feel like this is actually more high level than the star.
It is. Yeah. No, it is. This one is. It's higher level in that like you do less particular adjustments to like how to describe it. I mean, one is affecting the transition functions and the alphabet. The other one basically doesn't change those, but changes at a lower level what you're doing with the two machines you have access to.
So before you begin, you have to be in a special state where you read in every character of X and change it to X comma X, right?
No, because we're just trying to prove that this machine M prime exists that accepts the intersection.
But it, if by our definition of a Turing machine, it is given a string.
It's given a string, but the alphabet is an input. So here's the thing. If I have a machine M1 and a machine M2, they certainly they must be over this. If we're talking about intersection, they have to be over the same alphabet. I'd assume they're over the same alphabet because otherwise
Yeah,
it's
but
weird. But anyways, let's assume they're over the same alphabet for a second. So we need to prove that a machine M prime exists that that decides their intersection, right? If both of these are decidable, presumably.
But on the date at the beginning
Yes.
of this intersected Turing machine M prime, we're going to have the string itself. So what I'm saying is, you want to start off like in order
Not
for
necessarily.
but like that's how he defines it.
I'm trying to think how. So he's saying that decides their. You're right. Yeah. You're right, because it needs to decide their intersections. You're given a string that would be given as input to either one, and it outputs accept or reject if they both
To
accept or
run
reject.
it on
otherwise.
this, like you, this
Yes.
processes tuples on the tape.
Yep.
And like basically the idea is like if you only had one string,
Yeah.
you couldn't process it because it could get removed by the first element, which is why you want to put it
This
in
is
like
a pretty easy thing to do at a low level, though, right? Because all you do is you look at a character and you say write the
XX.
tuple of it. Yeah, exactly. If it was two different tapes, this would be complicated.
Yeah.
But because you just need the same symbol, your first. So yes, here you do have to dig into the low level stuff a little bit, right? Because you start with some input. You're gonna start on blank. You're gonna move right. You're gonna see a symbol. You're gonna write the tuple that contains that symbol in itself. Right.
Oh, so machine 1 would write. So machine 1 would have to
Okay.
write the symbol.
No problem. Have a good one.
Thank you.
I think it's clear that you know how to do this problem two different ways, and you'll be fine.
Okay. Thanks.
Whichever one you pick.
Yeah, wait, I'm having trouble.
Yeah, no, it's fine. So
So let's say, so I assume we have machine 1 and machine 1 gets a tape with an input, right?
yes, well, we have a machine M prime
Mm-hmm.
that is given an input. We know nothing about M. We decide what M prime is.
Okay.
It needs to decide the if this input would be accepted by M1 and would be accepted by M2. So we're going to, because we don't know what M1 and M2 are, we're going to have to define M prime with respects to M1 and M2.
Mm-hmm.
Does that make sense? Like I can't define some general machine that just decides this question all the time no matter what M1 and M2 are. And of course, M prime's description is going to depend on the intersection it's deciding. Does that make some sense?
Okay.
So let's say M1 accepts no strings and M2 accepts every string.
Mm-hmm.
Their intersection, the machine M prime is going to need to reject every string, right? Because it's accepting the intersection. If we define a new M1, let's say it just contains the string 1, and an M2 that contains the string 1 and 0, 1, we need M prime now to accept the string 1.
Okay.
Right, so changing M1 and M2 changes M prime. Think about it like a constant function. If I give you a function f of x, and I say f of x equals 6, do I need to define f with respects to x? No, it's constant, right? It ignores x, essentially. But if f of x is 2 times x, like, now I needed to use that x, because as I change the input, the output changes. That's why I said you can kind of think of this process like a function. You're essentially defining a way to take two languages or machines in that are two decidable languages or two machines that'll halt in. I think that'll halt. Does he say something about that? I'll have to double check that. Give me a minute on that later. But let's say they're decidable. So you take two machines that do halt in, and you output a machine M prime that decides their intersection.
Okay, so my question
You're defining
is,
that process, essentially.
So we can, do I need to mathematically go over how the tape that look with those tuples is constructed?
Yes. Because your input is still an input like the ones that would be given to tape 1 and tape 2. And the input to tape 1 is just going to be, it might not be zeros and ones, but it's going to be, these are going to be part of sigma, right? They're going to be some part, sigma star I should say, right? These are going to, this whole, like x and x prime, it's the same input for both, right? But they're part of sigma star.
Mm-hmm.
This is part of sigma star, is part of a sigma cross sigma star. I need to be careful about what I say there. It's not sigma star, it's sigma cross sigma star, right? Because each element is a tuple of two elements of sigma. So this is not the same language anymore. Your input is still going to be in this language. Your machine M prime, thus, what's the language of the machine M prime? This is a tricky question in and of itself in some
Well,
sense.
it's the language?
What is the alphabet? Sorry, not language.
Is it
What's going to be in sigma for m prime?
is it gamma cross gamma? What do you mean?
It is gamma union gamma cross gamma. It's going to be this. So for our m prime,
Oh, so like it could be
sigma
I see. So
is
it could,
equal to,
because it's gonna get one.
I'm going to call it
element.
sigma prime, right? So I don't confuse it with normal sigma, because sigma is coming from our machines M1 and M2. It's going to be sigma union sigma x sigma. Because its
Okay.
input is going to be in this form.
Yeah.
It's going to turn it into this, into something of this form. Then it's going to work on the tuples, right? And
So if I read something like this one,
yes,
my first step would be to say turn that into 1, 1,
yes,
and then
and then move right. Let's say because the input's always to the
do I
right.
go back to the beginning and then
So let's start with this. When I see the first blank, what do I do?
move to the right?
Okay, cool. When I see 1, I do what you said, right?
Yeah,
You write
turn it
1,
into
1,
one.
and I move to the right.
Mhm.
If I'd seen a blank here, what would I have done? Because eventually I'm going to keep doing that until I see a blank. Now what do?
Do you stop?
I move. I don't write anything.
Oh.
I move left until I see another blank. Because then I'm back here. Does that make sense? So first, read blank, move right. Now, for every element of sigma that I see, I turn it into sigma cross sigma. Every element x of sigma that I see, I turn it into x comma x, like the tuple xx,
Got that.
and then I move right. And I keep doing that. If I see a blank at any point, which I will eventually because the input is finite, then I write nothing, and I transition to a state that moves left until it sees another blank. So it moves left, and then if it sees a character from sigma cross sigma, it moves left. If it sees a blank, it stops. Now what does it do? So now what do we know? What has changed? We had an input that was part of sigma star. What do we have now?
Now our input sigma cross sigma star.
So now we can run what?
We can do M1.
Yes, the
and-
modified exactly. The
Yeah,
modified
modified
version of
M1.
M1 based on this new transition function type thing. Remember, this is just an example of how a single transition would change. You can define this in general terms though, right? Like that, do you change the state? Do you change like the state that we're going between?
No.
We do change what it's reading though, right? And we don't change what state it goes to. We change what it's writing, but we only change this one in the tuple, right? And then we don't change which direction it goes.
Okay.
You might want to state, just to be like overly pedantic, that M1 and M2 like should have different names for all their states. If they don't already have different names, rename all their states so that they're different. Because think like I could technically have the same like, let's say both of them have 5 states, M1 and M2, and they're named like Q1 through Q5. Well, if they're both named that, then I can't have one state for both of their first states. I need Q1 through Q5 and Q6
Okay.
through Q10 or Q prime 1 through Q prime 5, right? You see what I mean? You gotta be careful a little bit careful that you're not getting overlapping definition, like titles for states. But that's pretty much like a one sentence fix.
Okay, and my last question
You can
is-
kind of say assume without, you could say, I think we would all accept, without loss of generality, assume that M1 and M2 states have different names. That all of
Okay.
their states are disjoint names. Just cover your bases. It's a corner case.
Okay. My last question is, do I need to do something to specify that when it hits that blank on the right that it needs to go back?
Definitely. That's a transition, right?
So how would I do
So
direction?
define new states that once again do not overlap with the states of the names of the states of M1 and M2. Let's call it I'll use Q negative numbers instead. So let's say Q negative 1 is our new start state. Or Q0. I don't know what our old start state. We definitely didn't use negative 1, or nobody else writes that. So I'm gonna write Q negative 1 is our first state. Okay? What does Q negative 1 do? It reads blank and moves right. And then transitions you to Q negative 2. Because we know there's only one blank there, right? So Q1 sees a blank, writes a blank moves right. And to Q2, I did the tuple in the wrong order. I guess I'll use B because he's been using B. I'm used to seeing that symbol as a blank on the tape. Q -2 blank, right? That's all that matters for Q -1.
Okay.
Q -2, what does it do? It sees some X, and then you've already told me what it, so it's, if it sees, if it sees a blank, then we have to move to, then where, what happened?
I could say like Q -3
Yeah,
and
yeah.
then BL, right?
Exactly.
Okay.
But if it saw anything else,
It would just.
if it sees
Can I say
X
it stays at Q
not
-2?
equal to B, there's definitely a more elegant way to do that, but I don't, my brain is turned off at the moment. Okay, so, right, if it sees an X not equal to B, what does it write? Well, it stays in the same state
Okay.
this time,
I
right?
see.
Because it's just moving right, and
And then
it
it's
writes.
X, so then Y.
Yep.
Okay. And so then I'd also have to define Q -3.
Yep, and then you have to define Q -3 as.
Would I just say XX to XX?
Yes, though
But I
if it's
don't wanna-
blank, you need to do something different, right?
If it,
You
but
could
if it's
actually,
blank-
you could actually just say X to X.
Okay.
Because like X isn't a single character. It's not an element of sigma. It is whatever you saw. Does that make sense? So like if you see a tuple, you rewrite the tuple.
Okay.
I would specifically define like some variable symbol and be like, yeah, like I'm defining X for any X element of those. Rewrite it except blank, right? Is blank's not part of sigma, right? Blank is part of the tape alphabet, but not of the characters. I'm pretty sure.
I don't know.
Well, it should be in the definition. Let's check. Q0 is the start state, so I guess I should use Q0, like, yeah.
Okay. I think
So
I get it. This now. Yeah.
it's the tape alphabet. Right. So it's not in sigma, so we don't have to worry about blank.
Oh.
So you can actually say, instead of X not in blank,
X
you can
in
say
sig-
X
sigma.
in sigma prime, which is in fact this, right?
Okay.
So for X in sigma prime, we write XX. And then for X in sigma prime, we write, honestly the easiest way to do this probably is just to reserve some variable and say X is some arbitrary element in sigma prime. And then you can just, like you say that above, and then you just define transitions with respects to X. Moves to Q -3, writes X,
Mm-hmm.
and
L.
I mean technically you could do it like this if you really want to be specific, but we know that this is the case just based on our rules that that's what's going to happen, but
Yeah.
yeah. So I'll call this Y then. I mean there's, yeah, you can do it either way,
Okay.
but this is Y. Having different variables for it might just help you remember what these are, like, this is a single character, these are tuples, but anyways, and then move left, right?
Mhm.
And if Q -3 sees a blank, what does it do?
Maybe moves right, but
Yeah.
then
Our start state actually has to be 0, so I'm gonna come up with a slightly different notation that I like a little better. Q0, Q0, Q1, Q2, Q1, Q1, Q2, Q2, wait,
yeah, that's good.
is that good?
Mm-hmm.
Good, yeah, this is Q3. I want it to go to
Can I say like QM1?
0 of M1.
Yeah, or can
Yeah.
I say like QM1 or M0 or something?
well, it would. This is telling me what machine it's from.
Yeah.
This is telling me what state it was.
Mm-hmm.
Right. So like, that's how I'm doing it. At
Okay.
least for now. You can
Would it
come
be,
up with any
would it be
reasonable.
wrong if I said like Q subscript like M10 M1
No,
comma
that's
0?
not wrong. As
Yeah,
long
I
as you
was gonna do
define
something-
it.
I was gonna do something. like that,
As
yeah.
long as you define it, it works. And then it writes blank. Are we allowed to not move? No, we always have to move left or right.
Yeah.
Correct? Okay, then what you gotta do is move left, and then. No, we don't want to go to Q0M1 yet then. Because we have to move in a direction. So we need to go to Q4, right blank, move left,
And since the
Q4.
tape's infinite, we can
just-
move left, like so we can move to the left of the blank. 'Cause it's
Yeah,
infinite, right?
So what we want to do is move to Q4. Now we go to M1, 0.
Yeah, I got it. Okay.
We see whatever. I mean, we see a blank. We know we see a blank.
Mm-hmm.
Write a blank and move right. Just so you're back on the start state in
Yeah.
the right
Yeah,
state.
and then I see it. Okay. Yeah.
Then you redefine the M primes. Then after M prime runs, you need to find the first spot again. You need to find the input. This is the other kind of
What do you
slightly
mean?
tricky part. So after M1 is finished running, it's going to be in some accept or reject state, but we don't know which. Fine, whatever.
Oh, I need to go back.
You need to, well, maybe you're left of the input, maybe you're right of the input. So if the original input is here,
Mm-hmm.
after we're finished running M1, what part of the tape is it M1 looking at? Could be looking at something here, could be looking at something here. So do you move right or left to get back to the input?
I would assume opposite of where you moved previously.
How do
Is that
you
wrong?
go back through your computation? How do you rewind?
I don't know.
Don't do it. Shoot, what a pain.
Well, you could say after M1 is done, then you just define another state where you just go back, kind of like the Q.
Yeah, but which direction do we move to go back?
Is there no way to know what direction you moved in?
Okay, I have a better way to do this then.
Actually, can you write?
Here, don't try. You can do this. You can totally do this.
Can I write like a left and right symbol?
I take back what I said earlier. We're not going to do it sequentially. You totally can. There's many ways to do it sequentially. But let's redefine this transition function one more time. Okay?
Because I guess, yeah, you could do them at the same time if it's a tuple, right?
Yes, you can. So let's have now pairs of states as well. Picking an arbitrary pair of states. Right? Okay, so that's a pair of states. If it moves to Q2, okay, I'm just going to erase all this because otherwise I don't have room.
Oh, I see. So could you do? So you.
Oh
do
no,
like-
wait, sorry, I'm mixing this up. I need. Okay, I'm redoing all of this. Sorry, we're gonna have 3 transitions now, right? This is the M1's transitions. This is M2's transition. Let's say this is Q1. Reads A. Moves to Q2. Writes A prime.
Is there a reason why you
Moves
can't?
left.
Why?
You know why you can't do this? Because one might want to move left and the other might want to move right. That's the problem. Okay, never mind. We're back to sequential. I remember why I didn't do them at the same time. Okay, so there's still a way we can do this though. I'm trying to think of the simplest. There's so many ways. There's just like infinitely many ways.
I
to
was
do-
thinking, is there?
I don't know. I'm starting to default move back to maybe doing the way he was talking about might be the easiest. Because this is the way Stuart was talking to me about.
Could I
I
say?
actually like it as much.
Could I say when you reach the end of M? Yeah. So could I say when you reach the end of M1, for example, you put a character that like lets you know if you're on the right or left side.
Yes. That is what I was thinking.
So
You
like
could
there's
replace the first
so there's
blank.
there's a blank at the end, right?
There's a blank here. You can make, honestly, the first thing you do, changing this blank to blank prime. Not blank prime. It can't be blank. But like, you change this to some star symbol. I don't know. Whatever. Like I was talking about before for marking the ends of the tape. You do that. And then what you do is you actually have 2 copies of all of the states from your machine M1. Oh, I need to write everything I just erased because I'm a fool. Okay, sorry. One sec. Let me rewrite what I was writing before. Q1, right? And then I had A. Q2, A prime,
R or L.
L, I don't care. Goes to Q1, M1. I don't know, where do I want to put this R? There's so many superscripts and subscripts already that I hate it. 1, I'm going to do R1.
Yeah, actually, could I just make? I could just make separate state. Do I even need to append a character? Could I just make states for going left and right?
One sec. God, I might be just missing something simple here, but it just looks like a pain. Oh, ooh, this is wrong, right? These are tuples.
Yeah. A cross B, or A comma B. Yeah.
Because we're just giving particular element examples.
Mm-hmm. Yeah.
Okay,
Or would the bottom?
The reason
top
that-
one be R or not?
the reason I'm doing this is that I need to add a new transition.
Wait, how come they're both
New. There's a good, because all these is indicating is I'm left of the input. I'm left of them. Let's call the star the middle of the tape.
Mm-hmm.
Middle. It's infinite in both directions, so it doesn't really. Middle isn't
I
really a
mean,
thing.
the last character. Does one of them need to be R?
No. That's right. This is what I wanted. Give me a second. New to M prime is a transition of the form. If you see. So. How do I want to write this? If you have the state Q cross B so basically if you have an instruction on a blank and it does and it goes to some element of Q and some sigma and some instruction I'm gonna make it specific again, like I did here. Just use specific examples to make this a little nicer in some sense. Let's say I'm in Q3, and I'm going to Q4. I read a blank. Go to Q4. Write anything. It doesn't matter. Call it C. And I'll move right, for example. Okay? As a hypothetical. For every transition on a blank, I did it backwards. I'm going to do it the same way as below. R3, L3, both read. We do copy this rule, but we also make a rule for if it reads the middle symbol. Oh, but we might write over the middle symbol. That's ugly.
So like, what I was thinking is you have those states like QR3 and QL3, and that way you know to transition to a state where you start moving in the reverse direction. So like if you have QR3 and you read a blank.
Yeah, but how do you maintain whether you're on the right or left side of the input? Oh, I know. If that's star star, if that's a tuple, star star,
Yeah.
you can always maintain a star because you're only adjusting the first star. Here. What I mean is get rid of this blank.
Yeah.
And insert the tuple, some symbol, the mid symbol, mid symbol. I'm silly. Can't believe I didn't think of that. See what I'm saying? So now we do know there's always a star in the middle. So
Okay.
if what I read no matter what I read, I don't want this to be a blank symbol anymore. I want it to be something else. C and D. If I have C, comma, star. So if I'm in the middle, I transition to Q dot 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 4. Q 4. D star. D star. R. What do I put in the dots? So, here, this state thinks it's left of the middle, and this state thinks it's right of the
So
middle.
is it right for both?
It's right for both, because now both are right of the middle. That's
Okay.
it. So basically, what we've done is we've doubled the number of states with respects to M1. We've made, instead of just Q1, we have QR1 and QL1.
Mhm.
And they do all the same things that R1 and L1, they do all the same things as Q1 did, right? QR1 and QL1 are identical. Except that all they're doing is they're marking whether we're left or right of the beginning of the input. Does that make sense?
Yeah.
So if we see that we're at the beginning of the input, we might change though whether we're left or right of the input. Does that make sense? Because here I'm in the middle of the input here.
Yeah.
I was left of the input or was right of the input, but
Just
now
right.
because I'm moving right after being at the beginning of the input,
Mhm.
I move one of the two directions.
Okay.
Then, we can define two reset states. If you were in an R something state, you go left until you see the beginning symbol. If you're in an L something state, like QL7, you go right until you see the beginning of the input. Whew. Does that make sense?
Yeah, I think so. I think maybe just on a lower level, can you just very quickly? I think I'll be able to figure this out, or at least
Okay.
get something
Sure,
for
sure.
the homework. But actually, the thing that I don't really understand is like, if you have a blank and then your input is to the right,
Mm-hmm.
like where in this definition does it actually say you can like be on the left?
So, the point is, there are blanks everywhere,
Mhm.
except where the input is.
Yeah.
But your tape head starts on the blank just to the left of the input.
Yeah.
That's all we know about the tape.
So
What's
how
your
can
question?
you ever move to the left of that blank?
Because there's more blanks. Blanks are tape cells. They just don't have a symbol in them, essentially. Imagine it like having an infinite line of boxes. And I fill up a consecutive subset of these boxes. Infinite in both directions, okay?
Mm-hmm.
For all intents and purposes, if you were like looking at a chain of boxes that went around the whole world, it would look infinite to you in both directions. But like imagine like, yeah, you just have some line of boxes, and I tell you these have objects in them,
Mm-hmm.
and none of the others do. And you start standing right here,
So are you saying
looking
that
in this box.
a machine could just be defined as just like read left and just always read blanks and
Yeah.
like write
Yeah, you could.
garbage?
I mean,
and like
you
never even look at the input?
Yeah.
Oh, okay.
You
I
could
see.
just wander off and be looking in these boxes for no particular reason
Okay,
and do nothing.
I see.
Um,
So there's nothing saying it actually needs to move right and process the input.
Not implicitly. No.
Okay.
Let me see if the machine halts though, because if his definition says the machine halts, that still doesn't mean it looks at the input, right?
It
could
does.
just
It does say it halts.
okay. That's helpful. But you know what you could do? Your machine could start by going to the 10 boxes to the left that have nothing in them, and then walking back over, and then starting. Right?
Okay.
Like you could do something meaningless before doing the computation. Does that make sense?
Yeah, I get
Like
that.
there's no implicit rule saying you need to read the input, other than the fact that we know it halts. But you could move, let's say you could look at 20 boxes to your left and then just halt and accept.
Okay, so
Right?
that's the reason why we can't just say it's always to the right of the input.
So right, yes. So let's say that, for example, I say that your process is to walk and look at this box, look at this box, look at this box, look at this box, and then halt and accept.
Mm-hmm.
What language are you accepting? And let's assume what's in the boxes are elements of Sigma.
Guess you'd accept any language.
Yeah, well, you would not any language. You would accept any string, which means you would be accepting the language that contains all elements of Sigma star. Does that make
Okay.
sense?
Yeah.
Because inputs aren't languages. Inputs are strings.
Yeah. Right.
The language the machine accepts is the set of all strings that it accepts.
Mm-hmm.
Does that make sense? Cool. I love Turing machines.
Okay.
I don't know how to program, but I know how to do.
I think this gives me enough to at least make a very good attempt.
No, I think you can make a really, really good stab at it. I mean,
Mhm.
so let's go through one more time at a high level. What are your goals? Okay? What is the first thing your machine does at a high level? Don't just tell me those states.
Yeah.
Just what's it doing intuitively?
Yeah. So what I think is it takes the input and the first pass it makes is it turns it into a tuple.
Yes.
And then when it goes back, it doesn't.
Okay, well
It
that's a
doesn't
step.
change,
Let's say
yeah.
resets. What if we said it does to the start now?
It turns the start into a tuple of star.
Yeah. I should probably use something other than star, just because we use star for like sigma star.
Oh yeah.
E
Just some
for
special,
end.
some special character. Yeah.
Or M is for machine, so we can't use that. I want to use middle. But,
Okay. Just some special character. I got that.
Okay, I'm just gonna use like. Oh my god, we used too many letters. It's a good Hebrew letter or something. It's like one of the alphabets we haven't used all the letters for. Hey for half, actually. Hey means half, so that's good. Well, hey is used for half on dreidel at least. So, let's see. So turns. Blank. Left. One left. Of input to. How do I do hey? Something like that?
Yeah.
Hey. New symbol, right?
Mhm.
New symbol to M prime. Okay, cool. That's a good start. 4. What do we do next?
So we would, I think after step 3 we would be at the beginning step of machine, the
Yes.
beginning state of machine 1.
Yes. So simulate
Yeah. So simulate.
M1. What are we also what information are we hanging on to though?
The second value of the tuple.
Well, more that too. I'll mark that as well, but only on first of tuples. And maintaining what information about our position?
The direction.
Maintaining position relative to hey. Well, actually, we don't know that hey is going to stay there. Position to x, comma hey. What do we do when M1 halts? If it accepts, we do what? Well, if it rejects, what do we do?
We just reject, right?
If
Or
M1 rejects, reject, yes. Because we want to accept only the intersection. M1 rejects, reject. 6. Times it. We're definitely running out of time.
yeah, it's 1. So
Okay. Yeah, we're gonna get kicked out in a second. But if it accepts, what do we do? M1 accepts. Well, first of all, why have we maintained whether we're left or right of the input?
so that we know to go the opposite direction.
Let's say if I want to reset to hey, let's say, or to x hey now. To x comma hey.
And how do I know how to do that?
You know, because if you're in QL something,
Okay.
you
then
need
I
to move right
Right. Yeah. Got it.
until you see comma something comma hey, and
Yep.
if you're you understand now.
Yep.
And 7. If we're still running.
So
This one's easier than simulating M1 because we don't have to maintain anything, really, right? We don't care if we destroy information.
yeah. So we just simulate M2.
Yep, just literally just simulate M2
Yeah.
because if it accepts, you accept,
Got
and
it.
if it rejects, you should reject.
Okay.
I think you have a better chance now that we've done
Yeah,
maybe
this makes a lot of sense to me.
Now that we've organized it and these steps
I have
are not
absolutely
trivial.
no idea how I would have reached a conclusion like this on my own, but absolutely no idea.
Yeah, I mean, it's like I said, once again, it's plausible that like there's an easier way to do this. Like at least one of these steps can maybe be simplified and to reach a better some insight.
This intuitively makes sense to me
Good.
because the second you wrote those tuples on the board, I was like, I understand.
Ah,
that.
good. Yeah, yeah. The other way is also kind of elegant. I'm sure though it has its own complications.
I
The
don't,
one
I
where
don't
like flipping the
I don't
machines.
understand the other way at all.
Ah, okay. Yeah, yeah. Anyways, I would go through it just for fun, but I need to not get kicked out.
Yeah.
So.
Okay.
Well, that's a long, super long video, but hopefully it's instructive.